Uh, First of all, we have allowed some 5 minutes for members to join in on the call. Then we shall have a short animated video for about 5 minutes that briefly introduces us or gives us an overview of what cloud computing is, and some of the things that are involved under cloud computing. Expert of today, Mr. Andrew Okello, shall have a question and answer session for him. Then we shall have a brief practical session, followed by a question and answer for that practical session. So allow me quickly share my screen and introduce us to that. Hope you can all see my screen. Yes?
Yes, we see it.
Okay, so this is from Simply Learn. Imagine you're the owner of a small software development firm and you want to scale your business up. However, a small team size, the unpredictability of demand, and limited resources are roadblocks for this expansion. That's when you hear about cloud computing. But before investing money into it, you decide to draw up the differences between on-premise and cloud-based computing to make a better decision. When it comes to scalability, you pay more for an on-premise setup and get lesser options too. Once you've scaled up, it is difficult to scale down and often leads to heavy losses in terms of infrastructure and maintenance costs. Cloud computing, on the other hand, allows you to pay only for how much you use, with much easier and faster provisions for scaling up or down. Next, let's talk about server storage. On-premise systems need a lot of space for their servers. Cloud computing solutions are offered by cloud service providers who manage and maintain the servers, saving you both money and space. Then we have data security. On-premise systems offer less data security, thanks to a complicated combination of physical and traditional IT security measures, whereas cloud computing systems offer much better security and lets you avoid having to constantly monitor and manage security protocols. In the event that a data loss does occur, the chance for data recovery with on-premise setups are faster recovery measures in place to ensure faster and easier data recovery. Finally, we have maintenance. On-premises systems also require additional teams for hardware, cloud computing systems, and resource allocation substantially. So now, thinking that cloud computing is a better option, you decide computing refers to the delivery of on-demand computing services over the internet on a pay-as-you-go system on a local storage device. You'll be doing the same types of models: deployment model and service model. There are three types of deployment models: public, private, and hybrid cloud. Imagine you're traveling to work. You've got three options to choose from. One, you have buses, which represent public clouds. In this case, the cloud infrastructure is available to the public. Two, then you have the option of using your own car. This represents the private cloud. With the private cloud, the cloud infrastructure is typically operated by a single organization. This can be managed by the organization or a third party. And finally, you have the option to hail a cab. This represents the hybrid cloud. A hybrid cloud is a combination of the functionality of the service models, PaaS and SaaS. Compared to on-premise models, data, virtualization, and middleware, cloud computing service models are hassle-free. IaaS refers to infrastructure as a service. It is a cloud service model where users get access to basic computing infrastructure. They are commonly used by IT administrators. If your organization requires resources like only have to manage the data, runtime, middleware, applications, and the OS, while the rest is handled by the cloud providers. Next, we have PaaS. PaaS, or Platform as a Service, provides cloud platforms and runtime environments for developing, testing, and managing applications. This service model enables users to deploy applications without the need to acquire, manage, and maintain the related architecture. If your organization is in need of a platform for creating software applications, PaaS is the model for you. PaaS only requires you to handle the applications and the data. The rest of the components like runtime, middleware, operating systems, servers, storage, and others are handled by the cloud service providers. And finally, we have SaaS. SaaS, or software as a service, involves cloud services for hosting and managing your software applications. Software and hardware requirements are satisfied by the vendors, so you don't have to manage any of those aspects of the solution equipment. The SaaS model would be the one to go. With SaaS, the cloud service provider handles all components of the solution required by the organization. Time for a quiz. In which of the following deployment models are you, as the business, responsible for the application, data?
I think it has been first because it's already. Maybe I skipped the part of introduction. Let me turn on my video. I hope you can see me. Yeah, my name is Mbarara, and I'm the technical lead in charge of the cloud path on the Google Developer Student Club team for Makerere University. Yeah. So at this moment, allow me to hand over the mic to our expert for today, Mr. Andrew Okello, to introduce himself and also share with us what he has prepared for us. Thank you. Over to you, Mr. Okello.
Hi guys, can you hear me? Hello. Okay.
Yes, we
Yeah, I
can
got a
hear you.
namesake. I got a namesake on that chat anyway. Sounds great. Right. Allow me just share my screen a little bit. I hope I don't have internet issues today again. Can you guys see my screen now?
Yes, you can see a screen.
Yes.
Okay. When it goes off, just let me know. Because I have internet connection issues right here. Yeah. So, like Pia said, I didn't like the word expert. Yeah, but anyway, I'm happy to be here. My name is Andrew. Yeah, you said much about me, but the expert part, okay, really, so genuine. Yeah, though I'm almost there. So my name is Andrew. Actually, very amazing. Actually.
Hello. Excuse me, I don't know if it's just me, but your volume is a bit low.
Okay, sorry.
Yeah, that's better.
Yeah, I was saying, I think I would appreciate your GDSC. It's one of the most active. It's still a plus for me because I've been seeing DSC MUK everywhere. When I got an invite to share with you guys, yeah, it was kind of hard because I had to schedule a few things, pushing in there, and all that. And I'm happy to be here today. So I'll be sharing briefly just about cloud computing, but our major focus will be more on what was the technology. So we shall be focusing on Google Cloud Platform.
Hello, Andrew.
Yes, please.
Your volume is still low. That's what is happening in the chat right now.
Okay. Okay.
Yes,
So
much better.
we'll be dealing majorly on Google Cloud Platform, which is a cloud service that is provided by Google. Though I'll also take you through a brief overview of what cloud computing is, and I think everything has been mentioned in the video. My name is Andrew. Currently, I'm a data scientist. I'm not so much into cloud because the entire data science field is so big. Yeah, but I've been trying to deploy a few things in and there on the cloud for some time. I'm currently working as an ambassador for Startup Africa. Uh, just a brief profile about me. One, I'm not so big, I'm not so old. I'm still a student at Mbarara University, where I run as an ambassador for Startup Africa and running the academy here at Mbarara. I'm also a mentor at the Open Code Foundation in California. So this is where we mentor computer science students to actually take on uh, the field of computer science. Amazingly, I'm also an ex-DSC lead from Mbarara University. Retired some few months ago in August when the new leads came in. I'm also an IT consultant at an negotiates and audit firm around Nakolabi. You guys who have been to Nakolabi, that chicken tonight building up there. Yeah, I'm also currently mentoring at GADS. I'm mentoring the GCP track. And my interests are just machine learning, data science, and cloud computing. Just a brief overview about me. So, what brings us today here? How do you define cloud computing? That's the entire thing. Okay. Now, cloud computing. I don't know how you guys understand the term cloud computing, but different people explain it in different ways. Uh, but I would take it as these five composures: the on-demand service, the broad network access, the resource pooling, the rapid elasticity, and the measured service. These are all definitions for cloud computing. Cloud computing, one, is an on-demand service that provides you a broad network access uh, to actually deploy your products or to actually uh, store your files anywhere in the cloud that you may feel like. So, like you had in the video, we basically have uh, three categories of cloud computing. Actually, sorry, we run what we call cloud applications. And these cloud applications, you guys have heard of. Let me see. You guys have heard of Google Drive. You guys have heard of OneDrive. Now, all these are applications that are actually giving you a service just to store your files, to store your documents, whatever thing you have, to actually just store them on the cloud. So they're giving you a storage, but as a service. You get. So this is limited. However, for us, the experts now, you guys who are into software development, you do not just want to use a service. You do not want just use Google Drive to just store files. Rather, you'd want to develop an app. You'd want maybe to just create your own storage premises just on the cloud. Now, this is where the cloud platforms comes in, where we bring you a platform as a service known as PaaS. So here you actually run your own applications on the cloud, you deploy them, you actually have a chance to maintain them and all that. But much as these platforms are actually providing providing us that all that kind of utility that is available for us to do all that development procedures and all that. We have guys who run their own private clouds. For example, I don't know, is it Crest something? Crane Cloud? I've heard about it. It's a Ugandan something. Yeah, we have seen Crane Cloud. This actually, these guys are just providing. They have their own private cloud provision service that they're actually putting for guys to use. So much as they are just a company, they are running their servers in their premises, and you who is in MOOC, you who is in one day can actually tap into their online services, store your videos there, deploy your applications there. I saw there was a challenge on deploying applications on Crane Cloud. It was very amazing. I got the information a bit late, but yeah, that's just a categorization of cloud computing. But what comprises of cloud computing majorly? So I bring you back to what we call GCP. Now, Google Cloud Platform is provided by Google just for us, the developers, to store to run our applications, to develop our applications, get containers and all that. However, uh, these people are so big. Google is so big. Google is in Asia. Google is in Europe. Google is in Africa and all that. So what they did is actually they decided to separate Google Cloud Platform in two different regions and zones. Okay. So depending on your location and depending on what amount you have your app to be deployed in. But remember that once you're deploying your application in a certain region, remember there's some hindrances. Like the services you get from a certain region are different from the services you get from another region. For example, I can say the services we get as Africans are different from the services the guys in USA get. So this is the kind of thing that you guys have to know before you actually go and deploy your application or just run your services on the cloud. Okay, you guys have seen what there are restrictions whereby they say this service is not available in your country. Maybe you could switch into another country. I've seen that with Huawei Cloud, where some services you have to tap them from actually South Africa if you're in Uganda, because regionally we don't have access to that kind of service. So we shall see the different regions that Google Cloud Platform is divided into. We run majorly three. We have US, we have Europe, we have I think Asia also. No, we have Europe, we have Asia. There is another region kind of not familiar. But when you come to Europe is divided into I think three. Yeah. We have if you scale down from the US itself, from the US you scale now down majorly to Europe, and Europe is divided now west and east and all that. So it depends really. You could choose maybe to a region of Asia, where you basically have your services running, maybe from China, maybe from Japan and all that. It really depends on you. I've not seen a service for Africa actually. It's surprising, but I'm seeing Google offices are slowly shifting to Nigeria. So I hope in the next 2 to 3 years we shall be having services running for Africa, but they will be limited, like I've told you. Okay, so when later on we dive into understanding Google Cloud, the Google Cloud platform, we have different compute options that you guys could venture into. Like I already told you about infrastructure as a service, platform as a service, and also there's another one. When we start dividing them, it really becomes so interesting. So when you dive into the compute options that Google Cloud Platform provides for you, you have very many different options. The compute engine that actually allows you to use to abstract the different operating systems of Google. They're all here in the compute engine. The Kubernetes engine that allows you to create your containers, all here. The app engine that allows you to deploy your applications, all on Google Cloud Platform. The App Engine standards where you can actually run mobile and web applications just for you to, have that trust. Then we have the cloud functions where you run the serverless mode, where you don't have to deploy your own server, but rather Google provides for you their server for you to use. But of course, the servers are not free. You must be having credits actually to use the servers, or you have to pay some dollars. But it will now depend on the kind of infrastructure that you're running, the kind of software that you may be running, because software is varied. There are those that are heavy, there are those that are light. Okay, so we'll look at this computing services. I think I'll look at our compute engine at the end of this whole session, uh, because due to time and the entire GCP platform is really so big. So I got some few labs to run on Google Compute that we can leverage on. I hope I'm still I'm still on the cloud. Am I?
Yes.
Okay, thank you. All right. Okay. So what does Compute Engine have for us? Okay. So now, you guys have heard of virtual machines, how you create your own virtual machines and all that. So, when you go to the cloud, you actually don't use your computer resources. You get? You actually have an abstract of computer resources that are provided to you by Google. Okay, we're focusing on GCP. I don't want to go much wide into Amazon Web Service and Salesforce because it becomes wide. I just want to focus on this small area that can give us just a light on Google Cloud and other cloud platforms. But whatever happens here is not any different from what happens in Amazon Web Service, what happens in Salesforce, and the rest. Okay, so the Compute Engine one, it allows you to run your virtual machines. uh you guys know how to create virtual machines, where you guys have the virtual box and all that. So without doing all that hasty work where you have to download the software, download virtual box, then run the service, have to actually install Linux on that service, it's really so very hectic. But the Compute Engine provides all this for you. You create your own virtual machines, they even provide you a console to run them. You can run images, you can run Linux, you can run Windows, you can run any kind of operating system on Compute Engine. Now, what happens is that, depending on the kind of images you're running, the region you're in, uh, these guys offer you pricing. Very amazing that if you don't have credits, you cannot use a cloud platform. Just like the way when your drive is full and you have to pay for an extension of that drive and all that, the same thing happens here. Okay, so these guys that they give you storage. And another amazing thing is that you only pay for what you need. Okay, you don't need to pay for too much or less, because these guys actually scale for you. They scale the size, a batch of storage that you're using, and you exactly pay for that. It's very interesting, right? Because now if I'm deploying my app on App Store, maybe my app is lighter than, let me give an example of a light app. Okay, I don't know. Let's look at okay, let us look at aims, because all of us are at campus. Let us look at aims, look at how heavy aims is, and also look at maybe your app that is just running on just to receive, okay, like a phone app, like the phone call app. It's very light, just have to call, choose a number and all that. Very light compared to aims, which is very heavy. Now if I'm to deploy something on Play Store, I really have to pay, like the person who is who is actually the me who's having the dial up, and the person who is using aims actually you may find that we are paying the same amount of money, uh, to Play Store or App Store, whatever. But then, GCP says no. If your app is light, you pay for the light amount. If your app is heavy, you actually pay for the weight of your application. So when you're deploying, you must also take into consideration that, okay, this is the kind of application that I have, and yeah, maybe to take this. And the good thing is that when you're deploying this, these guys actually keep adjusting for you the money that you're paying. Either it's free or it's not, or depending, you know, you may have to pay $25, $50, depending on how huge your application is. You may be deploying 7 programs at once. You don't have to pay the same amount as me who's deploying one. Okay, so these guys give you the opportunity to pay for what you're using. Okay, you actually have the opportunity again to pick the memory and the CPU that you want to use. There are very many predefined GPUs and CPUs that you need. For those guys who do machine learning or who run code on Google Colab, these guys they provide you that GPU that actually helps you to do heavy machine learning projects, do computer vision, do image processing, and all that. So the same, however big or however heavy your application is, Google provides you the right GPUs to use to deploy your applications. I'm not focusing more on us on the guys who just want to, push your video to Google Drive, store your images to Google Drive or OneDrive, whatever. I'm focusing on you who's developing an application and not deploy it, who's developing a mobile or web, whatever application that you have, okay, or whatever deployment model that you have. Maybe you want to run machine learning. You can run actually machine learning on Google Cloud Platform. Very amazing that these guys are so fast that you can do anything that you want with them. Okay. Besides that, GCP provides you cloud storage. Like WS does, they provide you with buckets and all that, where you can actually put your data. This is very amazing that you guys have heard of Kubernetes, where you create your buckets and your containers. Create your containers and all that, store them there. So the same thing happens here. Your storage files are just organized into buckets, where you can easily manage them. So imagine I have a bucket that contains everything that's detailed in my app, so I can easily control them. And the good thing is, one, you have a location where your bucket is, so you don't need to search anywhere else. No, the platform tells you, okay, you created a mobile application, we containerized your application and deployed it in this region. So you actually have access to that. Very nice. These guys actually they encrypt your data, like they keep it safe. Even when you're trying to move it from one account to another, or from one's development account to another, these guys actually make sure that your details are safe. And amazingly, if these guys rarely run down, it's very rare to have a downtime on the cloud. Very rare. Apart from a few days ago when Google Cloud Platform went down. You guys who use Spotify was down. I don't know which other application was using Spotify. We was using cloud Platform. But in case such a thing happens, it's very amazing. These guys compensate for the downtime. Okay, they compensate your client, because once I've deployed my application on the cloud, it's up to Google to actually manage for me everything. I don't need to do anything besides just deploying my application and making sure that, okay, whatever I've deployed is secure. So after that, everything is left to Google. But remember, for you to use every application, you must sign what we call terms and conditions. There are some forms that you fill, agreement forms. Or maybe in case there's downtime, Google compensates you with this amount of money, because there are guys who use who mine money through the applications, and they want those applications to keep running. So what happens when your application goes down? So Google compensates for that time. Google looks at, okay, for every hour, maybe Andrew makes $200 from his application, but now we have had a downtime of maybe 20 minutes. So they will weigh and be like, okay, let's compensate Andrew. Because he was using our service and we went down. It's not his fault that our service went down, but he trusted us with his details and his tools for us to manage. He actually paid us the money that is for using our resources. Now we should compensate him. So these guys come in and compensate for you depending on a downtime that has happened. I wonder how much Google compensated Spotify, because the downtime was quite big. Okay. So IAM policies, you have control over the projects that you create on GCP. We have basically they divide it into editors, owners. Yeah, I think those are the two I know. So if you own a project, when you set up a project, you set before that, okay, I'm the owner of this project, but maybe I want I want who's on the chat. Okay, I know Halima. Okay, maybe I want Halima to contribute to the application too. What I do, I just have to get her credentials for Google, maybe her email address and all that, push her into the system and make her an editor, or even make her part of the owners of the application, so that she, in case she needs to make updates on the application, she actually has the access to it. So it means if the owner didn't give you access control to the application that you deployed or the project that you deployed on GCP, it will be totally safe. No one else will have access to it. It will only be you, the owner or the editor that you accepted to contribute the project to access it. Okay, so that's very amazing, very amazing. Okay, um, cloud storage, very big. Now, you wonder where Google stores all your files on Google Drive. Like right now, my slides are on Google Drive. So I'm wondering where Google is storing them. But no, uh, these guys actually have cloud storage. Okay, most guys know cloud computing as just storing files on the cloud. No, that's not it. So cloud computing is very big, and part of cloud computing is cloud storage, just a small subset. You know But I've seen most guys confuse cloud storage and cloud computing and taking them as the same. It's not the same at all. Okay. So one, Google provides you with cloud data store. One, you can do transactions. What do I mean by transactions? You guys have done transactions like just make sure that maybe this table is communicating with another. When I deduct an amount of money from this table, it reflects on the other table, and all this is tracked maybe in form of a trigger and all that. But you don't run complex queries on this. But good enough, these databases can be big. Google provides you that whole history, but remember, still you pay for this storage. For those guys who have credits for GCP, well and good. They vet using those credits. For those guys who don't have, sometimes you may have to pay some money. But of course, the size of database that you want to run is typically dependent on how huge your application is and how much you have, basically. Okay. Now I'm imagining what amount of storage these guys of Alibaba or Amazon or just Jumia, what kind of database they have. Did they develop their database alone and just pushed it to Firebase, something like that? I don't know. Or they got their own database and they gave it to Google to just they push it to GCP, and GCP manages everything, do the scaling and all that. We have Cloud Big Table. Uh, Remember, this kind of databases depend on how much you have and what you're running. Okay. We have Cloud SQL that allows you to run just relational databases like SQL, allow you to do online transaction processing, where imagine like banks are always transacting all the time. Money is going in and out and all that. So they use OLTP to actually track down this. And when you look at the capacity of this kind of tables, they're usually so big in terabytes, very big. And they have engines that actually run them particularly. Okay. what happens is every time you're using your application, these guys give you the quota that you've used. They do auto scaling of workloads. For example, today, maybe I had 1,000 users on my application, and then I have to pay for all the 1,000 users. And then tomorrow, I have maybe 20 users on my application, and then I have to pay for 20 users. It's auto scaling. Like you pay for what you're using. I don't have to pay like, okay, this whole month I'll pay $120 just to use GCP. What happens when people don't use my application tomorrow? What happens when people are many tomorrow and all that? When my application crash? No. These guys do auto scaling in that you pay for the resources your users are using. Okay. So if I've launched an application where guys can store their data and all that, every time somebody pushes their data to my application picks the data and puts on GCP, and GCP cashless the amount that I've used. Of course, my users are also paid the money to use my application. So Google will calculate how much space you've used for today or for tomorrow, and then they will tell you at the end of the month, okay, this is what you used, and you pay for the service that you actually used. Okay. You said like I've already explained that usage based pricing is very nice. So one, there are some requirements that App Engine also has that you have to use. First, you don't have to write to local files. Rather, you just open your project on GCP, and then work on your project live. Okay, I don't have to work from Android. Then from Android now I have to push changes again. But that's working locally. But real time, open GCP, you launch your project there, open the shell of your project, and push commands like you do on GitHub. Push commands and things are just happening on their own. Okay. So you don't have to use third party software. If I'm to do machine learning, I don't need to download Python. I don't need to download Anaconda. All those things. What I have to do is just come. I go to the machine learning side of GCP and start programming. Very amazing. And that's how nice these things actually are. But of course, this App Engine runs on specific versions. What I know, they run on Java, they run Python, they run Go, and I think they run PHP. I've not seen them running R. But yeah, these are some of the specific versions that the App Engine runs on. Of course, Java for embedded systems, Python for the scripting language and all that. So you can just script anything that you feel like doing. Okay, this is just a workflow of how App Engine works. So what happens is that at step one, actually develop and test your web application locally. After you've developed it, you feel it's okay, because sometimes it's hectic to just go on GCP and so you can work locally first, and then you say, okay, if it is working here, then it can of course work on GCP. Okay, now after that, you come to your compute engine, create a virtual instance, pick the type of server you want, and you deploy on App Engine. Okay, now what happens on App Engine is that you have containerization. They containerize your app and all that, and then after you've pushed everything to App Engine and you feel everything is running, you can debug on App Engine. Every nice thing happens there. These guys provide you with the scaling now. So we're like, okay, depending on the application that maybe Halima has worked on, this is what she requires. This is what she needs. You might have allocated too much memory space on your database. This gets reduced for you, or you allocated maybe little space on your database. This gets adjust for you. So everything is just done within the platform, and you find that your work is easy. Sometimes you push codes and they tell you storage not enough. Sometimes you run the app and they're showing you errors. There's no way, like you don't know where the error is, and you have to look for it. For example, if you're looking for JavaScript error, it may take years, and it's something small. Okay. Now, what happens there with App Engine? You can also use APIs. whereby I have just hit an endpoint and I have resources. I may be deploying my application here, but I want to pick some data from some point, maybe from somebody's app. And somebody has provided details in form of an API. So what I just have to do is just call that API. So every time I'm running, every time my app is running, it hits an endpoint somewhere and picks that data for my users also to use. Lucky enough, these guys have they dedicate for you such API that okay, depending on the application that you want, maybe you need an API, maybe the Google Maps API. So these guys hit for you that Google Maps API, give it to you. Okay. But remember, some APIs are not free. All that comes to your billing price. Okay. Yeah. Then, of course, you're trying to deploy, but why are you deploying? How are you going to monitor the logs? How are you going to debug? How are you going to do tracing? Maybe somebody was transferring data and the packets didn't reach. How are you going to trace that? These guys actually provide you with what we call Stackdriver. So what does Stackdriver do? It does monitoring, it does logging, it does debugging, and all those amazing things that you need to know on your application. So if maybe I want to view the number of logs in on my application, open GCP, go to Stackdriver, and I see the logs. How many guys are using my app currently? And I see a bunch of guys. Maybe I want to monitor how people are using my application. Maybe how many numbers I'm having per week, per day, and all that. You do monitoring. My application has crashed, and what can I do? I have to debug, get the code, check through errors and all that, then push it back. If there's an error, maybe on the software, this Stackdriver actually updates you. If somebody is not logging in, they can actually tell you, some person this with IP, this failed to log in and all that. Okay. So you can deploy as many times as you want, but these guys provide you all the resources that you need as long as you can pay for what you have. Now, when I talk of paying, guys be like, okay, isn't this thing expensive? But trust me, for everyone who has a business model, there's always that part where you need to get the monetary part of it. How are you going to get money? So this is how these guys are making their money. When you deploy, they scale for you all the resources that you need and tell you, okay, pay this for you to use the service. But what's the advantage of actually using using GCP? One, trust me, there will be no server downtime. It's very rare to have a server downtime with GCP, with Amazon Web Service, with Salesforce. It's very rare because there are very many engineers that are at the back of this just to make sure that things are well with Google services and Google resources. Imagine thousands of engineers are just seated at Mountain View just to make sure that everyone is comfortable with using the Google services. Imagine tens of thousands of developers. And then also be sure that your information is secure, because it's only you who has access to your account. If you invited someone else to do editing on your project ID, it means you invited them and you authenticated them to use. So what happens when somebody maybe gracefully, by the mercy of God, they actually hack into your project and all that, they do compensation. Like I told you what happened when GCP went down, I think 2 days ago, and then guys were streaming music, were down on Spotify, Oracle was down also, I think, some time back. So all this, they compensate for you. And the good thing is that you pay for only what you use. Very nice. It's easy to deploy applications because these guys actually abstract for you all the resources that you need. Imagine I'm running maybe a Pentium machine. Now I have to develop my applications running Android Studio. Maybe I'm running TensorFlow and OpenCV and everything. It becomes too heavy for my machine. But if I just launched a link, went on Chrome, launched GCP, and I just got the resources that are online, it's very easy. I not have to buy maybe a new device, maybe install servers and all that. It becomes costly. So all this these guys provide for you, and you find it easy. So I just want to ask you, how much would you spend on buying a server for your company, and how much do you think you would pay for just to have maybe your resources running on cloud platform? You will look at all these costs in case maybe my server went down. Uh, what are the downfalls? How are my customers going to feel? What pressure do I have? But when you deploy something on cloud, you know it's reliable, it's available, it's accessible at any time, and you know it is secure. Okay, and anyone can use them at any time. I don't need to go to office to access maybe files from a certain server in my premises. Okay, now big data and machine learning in GCP is also another very important and critical area. Uh, for us who do machine learning and developing those AI tools, this is the best part to leverage in. Okay. For you guys who do that analytically, sometimes it's really so heavy to run OpenCV, to run TensorFlow, to come up with your own database. These softwares are really very heavy. And sometimes even they cause your machine to go slow. Okay? But then GCP gives you big data and machine learning, fully managed and scaled. We need too much, they give you too much. We need less, they give you less. So when you need maybe when you have less money, you pay for what you can afford. Okay, these guys give you data sets that you can use. Now Cloud Data Pro, Cloud Data Flow, and BigQuery, all this for those guys who do machine learning, this is for you actually. Now BigQuery, like I've told you, if you want to analyze, query some databases, pick out information of different transactions from your company and all that, you use BigQuery. Cloud Pub and Cloud Sub, this very actually amazing. That this allows you to do what we call enterprise messaging, whereby guys can actually interact. You guys have seen how we develop bots. Guys are now running AI bots on their phones. I don't need to talk to a doctor, I just need to have interact. So this is why you come in and deploy. If you need to do visualizations, what we call EDA, explorer data analysis, Cloud Data Lab gives you all this interactive things. So we can develop very interactive graphs, from plotly graphs to seaborne graphs to matplotlib graphs. All these are here. Okay. So for those guys who want to do machine learning, I'm going to take you through the GCP platform. You see how nice it is and what you can actually use the different services that I've talked about. You see them all lined there. Okay, now I'm here talking about cloud computing, but there are guys here who want to actually venture into just focusing on cloud. There are now cloud administrators. You can be a cloud architect, you can be an automation engineer, cloud consultant, you can be a cloud software engineer. Site reliability engineers are now existing, so all this is possible. And trust me, there are very few guys who are experts in cloud management and all that. So you actually love to leverage the field and come here, because now when I look at the company that provide cloud services in Uganda here, I think there are very few. So we need cloud architects, we need reliability engineers, we need consultants, we need automation engineers, and all this is possible when you have cloud knowledge. Okay. So with that, I think I have come to an end for this. I don't know. I'll hand the mic back to who do I hand it over to? The host.
Thank you very much, Andrew.
You're welcome.
Yeah, that was a very wonderful presentation. Very interesting.
Thank you.
So I'm going to open the floor to you guys. If you have any questions that you would like to ask Mr. Andrew, please go ahead and ask them. before we go to the short practical session. Any questions? There's a question here in the chat for Mr. Andrew. How much do you pay to test your machine learning models?
I've run 2 machine learning models, but like I told you, I've not had the chance to actually pay actual dollars for cloud. I've not had a chance to pay. Like, I've got credits. Usually I log into someone and someone gives me credits, so I use the credits. But for the application that I recently ran for my I think we had a solution challenge last year, right? Yeah. For the solution challenge, I think I was billed $25 to run, because I was doing image processing. So kind of the tools that I was using was kind of so heavy. I needed huge databases to just store those images, the GBs of data that I had to upload. I had like 2 GBs of data. $25. But remember, before you deploy your application, how much are you going to get? That's what you would consider. If I'm to pay $25, that's around 100 and something thousand. If I'm to pay $25, and my clients I'm actually able to get maybe 1M. Isn't it worth? Like I told you, you don't look at only the money that you're going to spend into maybe accessing the resource, but also you look at your application. Is it able to generate you money and actually pay back for the services that you're doing? Don't deploy things on the cloud anyhow. Okay, so don't deploy things on the cloud anyhow just because you want to deploy, but have a business model in you. If I'm deploying an app that is maybe like Eversend, those guys are making money. These guys actually realize this money within the shortest period of time. So $25 is not money to them. So I really needed a huge database on the cloud. I needed 5 GB of storage, and also now I have to pay for the server and all that. And then the engine I was using was a Linux engine, a GPU and GNU. I was using 2 of them at a go. So you see, it kind of becomes heavy. Okay, let me check another question on the chat. In case my app crashes, can the cloud charge me and they debug it on my behalf? No. They don't debug for you. You have access to your project. So what happens is, when you have access to your project that you need, you allocate them yourself. Because what happens if an engineer at Mountain View gives you storage that you can't pay for, maybe enters your code and makes changes that you don't need. So you own your code, you own everything that is that you've deployed on the cloud, and you control everything by yourself. So in case my app crashes, can the cloud charge me? Like I told you, if your app crashes, it's not their fault. Hey, Emma or Rogers, your app has crashed, and you need to make changes, debug. Okay. What is another question? What?
I have a question.
Wait, there's somebody on the chat. What exactly is Kubernetes? Okay. For those guys who use AWS, you guys have heard of S3s and buckets. Now, what Kubernetes does, it allows you to automate. It automates for you what we call deployment of your application. It makes it automatic for you, in that once you just maybe push a command, Kubernetes arranges for you and picks all the resources that are needed for deployment, and gives you, like it does for you by itself. Like for example, if I'm to deploy something, maybe I've not deployed apps on Firebase before, but I'm sure there are some steps that you need to deploy this. So now, whatever things you create along in order to deploy your things, maybe on Play Store, uh, Kubernetes automates for you. It creates for you the buckets that you need. It packages your application very well. It organizes for you the different subfields that are there, and everything runs smoothly. And that's the advantage of running on Kubernetes. So now guys are using Kubernetes to run on Docker, very many tools, because they allow you to actually automate everything. Like it automates for you everything. Let me see another one. So someone is asking about what? Docker. Now, like I told you, with Kubernetes, these guys provide for you. They provide you containers to actually run your application, package for you everything, and automate your deployment. Now with Kubernetes, now with Docker, is now different. What Docker did is that they picked the Kubernetes engine to actually make containers on their application. Remember, Docker is a typical application of itself, but they run Kubernetes. Why are they running Kubernetes? Because they want also to provide this kind of automation. They want you to have. They actually provide speed. They provide speed and make processing of everything very fast for you. Not gone much into doing Docker, because it's the same thing as doing virtualization and actually picking out the kind of machine that you want to use, the kind of GPU, GNU that you want to use, and virtualizing everything and making sure that your containers run on a virtual mode, in an extended mode. Okay. I don't know if there's any other question. We satisfied? Somebody passed in a form on the chat. What is that about? I don't know. Should I check it out or?
There's another question that has just come up, but for that form that is in the chat, that is the feedback form about today's session.
Okay. All right.
Yeah, we are requesting that that people give in their feedback so that we see how we can make these engagements much better for everyone.
Okay. So what's your recommendation, Docker or Kubernetes? Now, Kubernetes runs on Docker. Okay, Docker has Kubernetes in it, and also GCP has Kubernetes in it. But remember, Kubernetes is a product of Google. So when Google developed Kubernetes, these guys of Docker also borrowed that technology and implemented it in Docker. So you can deploy on Docker, you can deploy on GCP. It's nice to explore. It's really nice to explore. Like I'm trying to explore Docker of recent. I'm trying to really understand the whole architecture and all that. But it's kind of heavy, So that's another thing. Now Docker is kind of hard to do deployment of tools on. Much as they provide you the virtualization and all that of software and all the hardware that you need, I actually still recommend GCP or even Amazon Web Service compared to this. What path do you recommend someone to take if he or she wants to become a cloud engineer? Okay. Now, the way I learned these things, what I'm explaining to you now, I think I learned by myself. I think even my data science knowledge. I learned it myself, just going hands-on. One thing I can tell you that once you have passion for something, you always pushing for it. Okay. Now, for you to become a cloud engineer, one, choose the stack that you want to focus on. Do you want to be a cloud engineer with Amazon Web Service? Do you want to be a cloud engineer with Google Cloud Platform? Do you want to be a cloud engineer with Oracle? You want to be a cloud engineer with Salesforce? It really depends on what you really want. Okay, so you choose one, you choose the cloud platform that you need to focus on, and then you start slowly. Start watching those videos, try creating accounts and see if you can run. But still, I think GCP provides you with quick labs that you can actually use to interact smoothly with to actually understand the concept of deploying applications, creating compute engines, running machine learning models. So I think for the start, if you guys can have access to quick labs, I remember having access to quick labs. I got it from my lead. So I don't know, Halima, maybe you could see how maybe the members could have access to maybe quick labs. I know. Right now, those guys who are on guards under the cloud track, they are having access to Pluralsight for free, and they are running quick labs. So for us who mentor them, we come into just in case they have issues and help them try to see how we can solve the errors, what they're facing. But quick labs actually gives you orientation from the beginning of everything and all that. But still, once you create a quick labs account, I think they give you some credits, like I think 30 credits, I think 50 to 30 credits that you can use to start learning. But once those 50 or 30 are done, I think you actually pay some little money to get more credits. But I'm sure the Google lead is given credits as many as she wants. I don't know, she can even waste them because I know. So she has access to quick labs, so I think you can utilize her for now. Alima, am I lying?
You're not lying.
I know really what happened. So she has access to quick labs. I think she has all the credits in the world that she needs to use. Everything. Access the lead. Maybe through the cloud technician, you can, I was really looking for you. If I was following very well, you recommended us to actually do the project development from the cloud. What challenge of doing the coding locally and deploy it in the cloud? Okay. What's the challenge of doing the code locally and deploying it on the cloud after finishing? One, remember, if you're deploying something you're using the resources, these guys are actually billing you. Okay? Every time you're trying to run something, these guys are billing you. Remember, if I'm to deploy something, if I'm to start a project now, I may go through the project development phase maybe for 1 month or 2 months. Okay, but remember now, I've started this project, it's going for 2 months, but it's not going to be complete. And yet, if I actually worked on it locally, I'll do everything and just push on the cloud and be billed at once. Okay. So what's the instance of me being billed for an incomplete project? Because yes, being billed because one, I've virtualized the GPUs from Google. Google has given me their GPUs. They've actually given me all access to resources, and they've allocated me the databases that I need to use. Okay, once they've allocated. But at the end of the month, these guys bill you again. So you realize that you're actually wasting time. So if you can develop locally, finish your entire application, and then open GCP and push those commands and all that, upload your application on App Engine, and those guys bill you at once, it's very fine. It's actually cheaper. But if you're so very sure that you can deploy something within hours, seconds, or 2 minutes, it's very fine for you to deploy direct. Okay. Okay, I think the rest are for Lima. Alright, I think that is it with the questions. I don't know if there's any.
Thank you very much, Andrew.
Okay.
I don't think there are any other questions in the chat.
Mm.
So right now, allow me invite Halima. She has a short practical presentation for us. Please, Halima, take over.
Before I actually hang up, sorry.
Yes, please.
Um, I need help from you guys. I launched a product. I launched a product a few months ago, and now I think it was nominated for the Startup Uganda Awards. So under the university category, there is Eastcat. I want you guys just help me. I'm going to push the link on the group in the chat here. Then just look for that section of university innovations and pick Eastcat Uganda and just help me vote. It's just that kind that I need. I need that
Please
help.
share the link.
All right.
Yeah,
I'll just.
we shall be more than glad.
All right. Thank you.
Yeah, thank you.
Yes, I'm here. Thank
You can
you
take
very
over.
much, Andrew, for the insightful presentation. We are glad to have you. Thank you very much, guys, for joining. Right now, I'd like to take you through. I have some credits that I got for every one of us that is interested in Quick Labs. I'm just going to take you through a short overview of how to do Quick Labs so that you guys can go ahead and do them by yourselves. So I want to first know how many of you have Quick Lab accounts. You could just type in the chat yes or no so that I know. Yes, no, you have. Of course, Andrew, you have. Okay. It's okay if you don't have. It's okay. Okay. All right. Okay. So I'm going to share this link that you're going to be required to open in incognito window. Make sure I open it in incognito window.
What is incognito window?
Hope you're using your PCs or you have them closed. The password I'm going to share with you only lasts for today. So if you don't use it, you don't have access to these Quick Labs. So I want us to follow through together. So I'm going to share this link and then you're going to open it in incognito window. There you go. Yes. Okay. When you're done, you can say I'm done. Or you can just type yes in the chat. You done? Okay, so you're going to click on let me first confirm. So I enrolled for create and manage cloud resources. Hope you can see that. So there is a button that has enroll. So you're going to click on it and enter this password. Okay? I'm going to share the password in the chat. It's the very first.
Halima, could you please share your screen?
I'm going to share later.
Oh, okay.
It's okay to share later, not now. Not now. Share my screen. I will share later. Okay, let me just share. That's the password. So use that password to enroll. And then when you enroll, we're going to go through the first lab together. So are the people that don't have accounts finding any trouble? Oh, you open the link that I've shared with you in the incognito tab. You're going to okay, let me share my screen. Let me share my screen. So when you open the other link I've given you in the incognito window, this is what you're going to see. So I'm giving you access to these resources. This quest. So it's called Create and Manage Cloud Resources. This is what you're going to start learning about. So you're going to come here and enroll. When you click enroll, you're going to be required to enter that password I've given you. So you enter it here. Traffic light. Traffic light. So are we at par? So then you're brought to this page. Are we there? Yes, yes. No one is left behind. Okay, now we're going to start. Okay. So let's start the lab. Where am I? Oh yeah, here. I've already done it, so it's already ticked. So you have been given 5 credits. You'll be able to do this lab because it's only taking, this one is free actually. So we have 5 credits. So after this lab, you can be able to know how to create a virtual machine, start on the compute engine, on the Windows, getting started with all these. All these are taking one credit. Even this is 1 credit. About when you want to get to know about Kubernetes engine, or this is taking 5 credits. So you stop here. But after you complete this quest, you will be given provision for the quick labs for the entire month. And also when you complete this quest, you'll be given more credits to navigate through the other quick labs. So now let's start. This one is 45 minutes, but we can even use less. Hope you can see my screen. If you cannot, you can just speak up because I cannot see the chat and everything. So it is advisable to read through before you start so that you don't waste the credit, because you might start and then get stuck in the middle and then you want to go back and you cannot go back unless you're just ending the lab. So we are going to go through a tour of Google Cloud. It's going to be a hands-on. And yeah, this is the overview. You can read through if you want, but I'm not going to read through all this. You're going to read through because you have access now, but this is what you're going to be able to learn. In this lab, we'll learn about the labs platform and identify key features of a lab environment. I'll learn how to access the Cloud Console with specific credentials, learn about Google Cloud projects and identify common misconceptions about them, then learn how to use the Google Cloud navigation menu to identify types of Google Cloud services, learn about the primitive roles and use the Cloud IAM service to inspect actions available to specific users. Also going to learn about the API library and examine its chief features. These are the prerequisites. but we all qualify for this. So you will read them on your own because now you have access. These are the lab fundamentals. These are the features and component, regardless of the topic or expertise level. All labs share a common interface. The lab that you're taking should look similar to this. Yeah, it looks like that. Okay, so it has the start lab button, it has the credit. You're able to see your credits. Can you see your credits? Can you see your credits? Please, can you see your credits? Are we following through? So, can you see your credits? How many do you have?
1 credit.
I want the other people also, the ones that didn't have accounts before. Yeah, Amanya is supposed to be having. Yeah. Yeah. I want to see someone else. I can't see them. Why? Why? Come here. On your account, to see my account, they're supposed to display here. I can't see them. Can you still not see them? Angela, Melak, can you guys see your credits? I want some other people said yes, it's here. Elisa.
Me, no.
There is signing on because you guys didn't have accounts, so you can join. I don't think I was able to create an account. You can do that. Okay, can you share please? Screen will get you. Rogers, are you there? Or anyone? Timothy.
Yeah.
Thank you. All right. Sign.
Oh, pole.
Time reaches 000, you lose access because all we created was a temporary environment. Some labs have tracking which scores your completion of hands-on lab activities. So you always have tasks to work on, and below down here, if you achieve that task inside the Google Cloud platform, there is a tracker. When you have not yet achieved that task, that tracker, when you try clicking on that tracker, nothing will happen. But when you're done doing that task, you'll be able to tick off that task inside this lab. Something else, some lab, yes. In order to receive completion credit for a lab that has tracking, you must complete the required hands-on lab activities. Yes, in order to receive the completion, you'll be able to, in order to receive completion credit, you must have accomplished all the tasks that you have to in a certain lab. So now this is going to take us through how to access the Cloud Console. So this is what we are going to do. We are going to start the lab. I have so many tabs open. Let's close off some. Okay. So yeah, we're going to start the lab. So when we start the lab, it starts counting up to 0. So we are provisioned with a username, a password, and a GCP project ID. So this is going to be our project ID. So then you open your Google Cloud Console. This is where you open. So a new tab comes up where you're required to enter the credentials site. Then here you enter the password. Come here and copy it and paste it. Next. Environment in Google Cloud platform. So now this is how the platform looks like. Right, so we're going to follow every step that is given to us down here. They give us steps for every lab. So we are done. We have opened the Google Cloud Console. This is the project ID here. You can read through when we're done here. So it just shows you how the console how it's supposed to look like. We've already seen these things. Password. So when the page opens, this is how it looks like. Same here. Since me, I've already done this before, it won't bring me this to click agree and continue. For people that are doing this for their very first time, it will pop up and then you have to click on that to check the terms and conditions and agree to continue. So there is a testing for understanding here. What field is not found in the left panel? This is the left panel where there is the end lab. This is the left panel. So which field is not found here? Of course, we have open Google Console. Here, project ID, password. These are usually questions that are asked based on what is in the lab. So there's no system admin. So the username in the left panel, which resembles this in the cloud IAM identity. The username in the left panel, which resembles this. Yes. So the username, this one, this is the person that is accessing the Google Cloud resources. So yes, this one is the person accessing them too. So now that we have signed into the Google Console, the Cloud Console, and understand the basics of the credentials, it's time to learn a little bit about the Google Cloud projects. So we're going to learn about the Google Cloud projects. So this is where we get the project info. Here. Everything that you want to know about your project is found here. The project name, the project number, project ID is here. So if you want to view all the projects that are running, in your environment, you get them when you click on this drop down arrow here. So this is our project name, project ID. So this is the project that is currently running in this environment. We have only one project. You can create as many projects as you. It has to be globally unique. That's why they name them after the okay. Yeah, you will see when you like advance to creating projects and everything, and it's provision too, and then just add in. Okay, so we've seen projects. What other thing do they want us? So now they're testing our understanding. You're going to you will go back and read through everything. Answer the following multiple choice questions to reinforce your understanding. An organizing entity for anything you build with Google Cloud. So what is the organizing entity for anything that you build in Google Cloud? Is it the Google Cloud bucket? No, it is the Google Cloud project. If you want to start building and get resources and everything, you have to have put resources. That's why they have a project already created for you. Or quick lab, you are only lab steps. No, that is false. This is not where we run our steps. We run them from the Google Cloud platform. This is false. So now we're going to go to the navigation menu. We want to see where the navigation menu is that has all the resources that Google Cloud Platform provides. They are categorized into 7. We have the compute, which is the variety of the machine types and support any type of workload. So in the compute, this is where you come and create all your virtual machines. In the storage, this is where you come and create your buckets, the big data, all those things. Oh no, big data. Querying and everything. And then the networking, this is where you come and configure your firewall, all those things about networking. Then this is where we come and we have the cloud operations, the tools, the big data, and then artificial intelligence. We can find the navigation bar here, the navigation menu, and this is where all the resources are. The app engine, the storage, the databases, the application integration, the networking, oh goodness. The monitoring, all these things, they're all found here. Right, running low on battery. Okay, let me first pause a bit and connect.